We are looking at general skill number 15 still. And in this video, we're going to focus on actually solving oblique triangles using the law of cosines. So let's jump in. We've got a couple of different types of triangles that we are interested in knowing how to deal with. The first type of triangle is an SAS triangle. This is a triangle where we are given two side lengths and the angle measure that is between the two side lengths. So when we're given this information, we're definitely needing to use the law of cosines, and there are a couple things that we need to remember. We need to remember that the law of cosines, we're going to start by using the law of cosines to find the side length opposite the given angle measure first. Then once we have that angle measure, we'll have a pair, an angle measure and an opposite side length. So then we can revert to the law of sines to find the measures of the other angles. Okay, but we are going to focus first on the smaller of the two remaining angles. And this angle will be acute. It's got to be acute. And then after that, we're going to use the triangle sum theorem to find the remaining angle measure. So here's an example of an oblique triangle where we're given two side lengths and the angle measure that's between them. So now this is in a slide that talks about SAS triangles, but as we are developing these skills, you should be able to take a triangle with some information and then determine what kind of information you're given so you know which tools to use. So you definitely want to know how to do this. This particular triangle gives us two side lengths and the angle measure in between them, so we know that this is an SAS triangle. We want to solve the triangle, which means finding every angle measure and every side length. And it is helpful for us when we are wanting to do that to organize our work by determining what we know and what we need. After we do that, it's easy to kind of use these steps and decide what we need to go to first. So our first step here is use the law of cosines to find the side length opposite the given angle measure. So we know angle B has a measure of 25 degrees, so we want to find the length of side B. Okay, so we know angle B, we want to find the side length B. So we're going to use the law of cosines to find the length of side B. And here we are, we've got B squared is equal to A squared plus C squared minus 2AC times the cosine of angle B. And we're going to go ahead and sub in what we know. A is 66 feet, so we're going to sub in 66 here. C is 100 feet, so we're going to sub in 100 here, and likewise 66 and 100 here. And angle B is 25 degrees, so we can sub in 25 degrees there. Now we can go ahead and crunch this in our calculator, and we would want to make sure that our calculator is in degree mode. And when we do that, we're going to end up with 2392.74. And so that's going to give us B squared, but of course we are interested in actually the measure of side length B. So we're going to have to take the square root, and we're going to go ahead and round that to the nearest tenth of a foot. So that gives us the first of our three pieces of information we need. Now once we have a pair, we can go ahead and use law of sines for the remaining angles. Now remember that the second step says we want to find the measure of the smaller of the two remaining angles, which will correspond to the shorter of the two side lengths. So we want to look at the measure of angle A. So let's go ahead and set up a law of sines proportion. Sine of 25 degrees over 48.9 will equal the sine of angle A over 66. We will isolate what we're trying to solve for. So first we'll isolate for sine of A by setting it equal to 66 times the sine of 25 degrees over 48.9. And then we really are not interested in the sine of A as much as we are interested in the measure of angle A. So we will need to use a sine inverse to get that measure. So we're going to use our handy dandy calculator, and we should end up with a measure of about 34.76 degrees. And we're going to go ahead and round that to the nearest whole degree. And we see that to be 35 degrees. And then the last angle measure, we'll go ahead and use the triangle sum theorem to find the measure of angle C. So we know that 35 degrees plus 25 degrees plus that measure of angle C will equal 180 degrees. That will give us the measure of angle C to be 120 degrees. And voila, we have solved our triangle. All right, so the next type of triangle we're interested in is an SSS case where we know all three side lengths but no angle measures. And so in this case, we are going to use the law of cosines to find the angle measure opposite to the longest side length. So we're looking for the largest angle measure first. And we're doing that really to prevent any kind of ambiguous case scenarios from creeping in. All right, and then after that, we're going to use law of sines to find the measure of the two remaining angles. So here we have an example where we're given three side lengths. And we know that this is going to be a side triangle. And we are wanting to solve this triangle. So we are going to go ahead and organize our work like we did before. And then, like it says in step 1, we are going to find the angle measure opposite the largest side length. So we are interested in finding the measure of angle A. And we are going to then set up law of cosines so that we have angle A in this position. So if we've got angle A in this position, that means side A is on the other side of the equal sign. Okay, and so we're going to go ahead and sub in everything we know. And in this case, it's going to look a little bit different than with SAS. We're going to sub in our side lengths everywhere we see ABC, and we are going to end up solving for cosine of A. Now, in order to do this, we are going to need to isolate the cosine of A, and so that means pushing this 2 squared over to the left, pushing this 3 squared over to the left. So let's do that much first. So we've got cosine of A is equal to 4 squared minus 2 squared minus 3 squared. And then we're dividing out the coefficient to cosine A. All right, so divided by -2 times 2 times 3. We'll clean this up a little bit. And we've got 16 minus 4 minus 9 all over -12. And of course, to actually get the measure of angle A, we will need to take the inverse cosine. All right, and so once we simplify this numeric expression, we have the cosine inverse of -1/4, which will give us about 104 degrees. So we've got the first of our 3 pieces of information. Now again, we have a match, a pair of a side and an opposite angle where we have the information for. So now we can go ahead and use law of cosines to finish this triangle. So let's do that. Set up our proportion. The pair that I have, I'm putting in the middle, sine of 104 degrees over 4. And that's going to equal the sine of angle B over 2, and it will also equal the sine of c over 3. So let's focus on this side of our proportion, these two ratios, and we will say the sine of angle B is equal to 2 times the sine of 104 degrees, all divided by 4. Of course, then B will have to equal the inverse sine of 2 sine 104 degrees over 4, which we will get from our handy-dandy calculator to be about 28.9 degrees, and we'll go ahead and round that to 29 degrees. And we'll do the same thing for angle C. We'll say the sine of C is equal to 3 times the sine of 104 degrees, and that's all divided by 4. And then we'll isolate our C by making that a sine inverse and use our calculator to crunch that. We should get about 46.5 degrees, which we will round to 47 degrees. Now, it's always a nice idea to use triangle sum theorem here to verify our angle measures, and we should end up with a sum of angle measures that equals 180 degrees, and we do. So that rounds up this video. The next video we will talk a little bit about Heron's law to find, or Heron's formula to find the area of an oblique triangle when all we know are the side lengths. Stay tuned and I'll see you there.